All right, so this board is basically talking about the journey we've taken for 7 weeks now. We're dealing with parabolas for this entire unit so far. And we've learned about these 3 forms. We've learned about, remember, standard form. Had our equations where we were taking the A, B, and C values and able to figure out some things from that. So if I was in standard form, by the way, this equation here is the same as this, and it's the same as this form down here. It's just been converted between the 3. So if I'm looking at this standard form equation, what's my y-intercept? How do I know that that is my y-intercept? My c value is always the y-intercept. So when we're in standard form, it's really easy to find the y-intercept. It's also really easy to see if it's happy face, sad face, if it opens up or down. So what is my a value in this case? Is it positive or negative?
Positive.
Positive, so we have what kind of situation? Happy or sad face?
Happy.
Happy face. It opens up. If it opens up, is it going to have a maximum or a minimum? Minimum at the bottom. Okay, good. So if we're in standard form, we're easily able to find the y-intercept and if it opens up or down. If I had it in factored form down here, it would be easy to find the x-intercepts. Remember, we just factor it, we make each expression equal to 0, we solve that, that's where the graph is going to intercept the y-axis. So to go from standard form to factored form, we learned these 2 factoring methods, x method, super x method. We have to use the super x when we have our a value is not 1. Okay. So we know these two factoring methods to get down to factored form. So if I'm down here in factored form, it's easy for me to find my x-intercepts and see what we have. We have x plus 2, x plus 6. So what are my 2 x-intercepts from that? Say it loud. Daniel, what do you say?
-2, -6.
-2, -6. If you didn't know that, you would make them equal to 0, solve, and you'd get -2. Equal to 0, solve, you get -6. So you see, before we had to do a lot. We had to do much more work when we didn't know all 3 of these or how to go between them. But we can go from standard to factored. Today is what is new. And this is the last little bit as far as how we're going to manipulate parabolas for a little bit of time at least. If I want to go from standard form to vertex form, what can we find in vertex form that's helpful? Remember, it was really quick to find. We could find the vertex. So we'll grab the y-intercept up here, but yeah, you can find it in any. You can find each of these in any. So here, we also find the line of symmetry pretty quick. All right. How we're going to do that is by learning about completing the square. Completing the square allows us to solve for x, or just transfer it from standard form to vertex form. So this is the whole big picture. And part of the assessment, not this week but coming up, is going to be you're given one of these quadratics, and you have to use these methods to find and graph it all together. Unless you can. Okay, so just keep this big picture in mind, and then we have a process. So we have a process here that does have steps. I think now we can see how it fits into the bigger picture. We just want to have this as almost like a tool that we can use to go between standard and vertex. So, completing the square allows us to convert into vertex form. And solve for x. Solve for x, or x-intercepts. You may have seen this before, but in particular how it works from converting standard to vertex. We're going to use this, and there's some really nice parts to it that are going to happen exactly the same every time. So we're going to use this as our example function here, so go ahead and make sure you have one good example. And a lot of this is pretty dependent on following the steps. That's where we're going to start with that. And then I'll give you another kind of problem that goes further at the end here. All right. So go ahead and jot down the first 2 steps, and then we'll go ahead and complete those. Those are pretty quick. Step 1. Somebody read it nice and loud. Anybody?
Make function equal 0.
Great. Okay, we're going to go ahead and make it equal to 0. Whoa. Desk wars. All right, step 2. Somebody else. Jason, can you read that loud?
Make C to opposite side of the equation.
Uh-oh. Move C to the opposite side of the equation? We're going to move it instead of make it.
Oh, it's a move.
Right here. You're reading that and then
Wait.
that?
Yeah, move C.
You said make C.
Oh!
How do I do that? How do I move my C value? Remember, that's our 12. It's our y-intercept here, the C value. How do I move it to the other side? It's plus 12, so
Subtract that.
you subtract it. All right, what we end up with on the left is minus 12 is equal to x squared plus 8x. So what are we missing on the right side now? If I was just looking at as far as a trinomial goes, I don't have my C value here. Now, what I'm going to do is I'm going to use completing the square from here on out. So this is a very special way to factor, and this is always going to be the kind of guide that we're going to be using. Because I know that if I take my B value, 8, and I divide it by 2, and then I square it, I do end up with 16 here. And what I'm going to do with that 16 is take it and put it on either side of the equation. What that allows us to do is now have a trinomial to work with on the right side that is easily factored. Completing the square, that idea of a squared value, is going to come into play right here. So I know on the left side we end up with positive 4, but the right side, this is where I want to use the x method to factor that try to 2 expressions. So let's see what happens. C is on the bottom, E is on top. What 2 values multiply to give us 16, add to give us 8? 4 times 4 is 16, 4 plus 4 is 8. And here's the thing, because it's completing the square, and we did this special b over 2 squared to complete our trinomial, I've created a perfect square here. This trinomial is going to end up with a 4 and a 4. In other cases, it might be a 6 and a 6. No matter what it is, we've completed the square, so our values are going to be identical, what we come up with here. So watch this first step. I know that it's plus 4 and plus 4, and then somebody tell me what we can do to simplify this right side, because there's something that's redundant. Bless you. Yeah, Isaac, what do you think?
You could square root it.
I don't want to square root it.
No, I mean like square it.
Oh, that's different. Okay, so what you're saying is these are the same, right?
Yeah.
So what you're saying is it's this squared.
Yeah.
Excellent. Thought that's what you meant. Sigh of relief. Okay. All right. It is kind of mechanical going through the steps, but what it allows us to do is get to the vertex form. The last step here is to simplify. We did so, and now move everything to one side of the equation. Get everything back on the one side. So let's see. It doesn't matter, but I would suggest let's move that 4 over to the other side. And how will I move a positive 4 to the other side? Just subtract it. Cancels on the right. I reassert this is f of x is equal to x plus 4 squared minus 4. All right, let's double check ourselves. Is that in vertex form? Is that in vertex form? Let's see.
Yeah.
Yeah, right down here. We have our k and our h value. Now we can pull out our vertex really quick from this. So you see we're using these tricks to go between the forms so we can just take the information out. We have to do a lot less if we're really clever with these manipulations. All right. Thumbs up, sideways, or down. Let's see.
Do we have to solve for x?
Right, that's going to be the next step. How about so far we've done? Thumbs up, sideways, down. Okay. Okay. Thank you. Thank you for reminding me.
Oh, yeah.
All right, so we do have one more step because for honors for us, really we're also using this as a chance to solve for x. So what I'm going to do is take this step right here and pull it to the side. 4 is equal to x plus 4 squared. All right, we worked our way all the way to have it in vertex form, but I'm going to move back one step to solve for x now. So let's look at this close. This quantity is squared. How do I rid myself of this squared part over here on the right? Instead of squaring it, what should I do? The inverse is? Just one side or both sides? Square root. Square root. Now I know those cancel. Remember that when we're doing a square root, if our answer is a square root, we're going to put plus or minus. Because the square root of 4, I know this one. You may not be able to solve it, but square root of 4 is 2, but it's also negative 2. Negative 2 times negative 2 also gives us 4. So in this case, let's see what we have left over, plus or minus. Square root of 4 is x plus 4. Minus 4, minus 4. Negative 4. Let's go ahead and change the square root of 4. Let's just make it 2. So plus or minus 2. That's going to be my x values. And I don't mind if you leave it in that form, but really what this is saying is it's either positive 2 or negative 2. So we can find both of those answers individually by making one negative 4 plus 2, negative 4 minus 2. All right, we're going to do a couple of these, so don't worry. The first one doesn't click all the way here. So what do we have? We have x is equal to negative 2 and negative 6. So that's how we would get all the way down to solve for x. Isaac?
Wait, about finding 16, how did you come up with 8 divided by 2?
Oh, this? I didn't come up with that. That's one of the guidelines and rules for completing the square.
Okay.
Yeah, just like when we found the vertex, remember, is negative b over 2a. This is kind of like one of those. But here it's just b divided by 2, we square it, and we have that new value. All right, is everybody good with this as far as I can erase this and try to work on the second problem? Yeah? Maybe? Thumbs up. Okay. I know the first time around this might seem cumbersome. We're going to take another look with another example. Let's do, that's what we did in the warm-up.
Yeah.
Okay, I'll show you. Not right now. I'll let you do it again.
You forgot to erase it. I was thinking